Hi, this is Boyd Sheets, and today I'm doing my physics project on the Bernoulli principle and a little bit of Newton's third law, and I'm going to demonstrate it through flight and how a plane uses the Bernoulli principle and the Newton's third law to achieve lift. But I'm going to start off just with a basic little demonstration of Bernoulli's with this piece of paper. So that's just a little demonstration, and Bernoulli's principle says that the fluid air moving over the top, the faster that it moves, the lower pressure it has, and so with Newton, equal and opposite reaction. When the lower pressure is achieved, then the higher pressure down below it pushes up, and you have that lifting of the paper without, lifting it from the bottom, just from blowing over the top. And so now I'm also going to get into Bernoulli and Newton's down here. So with Bernoulli, it can be talked about through air and fluid, and I'm going to show you a little example of fluid. So what I've drawn here are two pipes from like looking at above with water, and then here's one as if you were looking through the pipe. So these are pipes. So if we're looking through the hole, these two here are static, meaning they're not moving, they're just sitting within the pipe or hose or any kind of container. And that is static pressure, as Bernoulli puts it. And what that means is that while the liquid or air is within this container, it constantly pushes out pressure on its surroundings. So if we see here, if we were looking down, it's pushing up, and vertically and horizontally, it's filling in the thing. Now the next part is that when you have a dynamic pressure, you have fluid moving through the pipe or hose, and Bernoulli's principle says that with this movement you have lower pressure, so the pressure becomes lower on the sides and everything else, and moves through quicker. And so that's how with fluids you see the movement of the fluid causes less pressure. Now to put it with air, I'll move down here and demonstrate. Okay, so now I'm going to demonstrate how Bernoulli's essentially lifts the plane. So we'll just draw here a little wing from the outside angle like this here, like that. So with Bernoulli's, the air will be moving. If the plane is going this direction, the air will be moving like this, much like a slipstream, like this here. So when the air hits, it bounces off and goes this direction, and with Newton's third law, the opposite reaction would be this way. So it bounces this way, we get it this way. With that upward motion, Bernoulli states that the faster the air goes, the less pressure. So when you have low pressure up here, again, the opposite reaction, it moves up. And so essentially that's how the plane lifts. The faster the air on the top, it lowers the pressure, and the pressure down here remains the same, but as this goes up, and then it goes forward because it becomes more dominant, so it pushes its way up, Newton's third law. And the same goes for the air back here. As it interacts with each other, you have turbulence and everything else that also creates lift because of opposite, or equal and opposite reaction. So that is how a plane uses its wings and Bernoulli's principle to lift itself on the ground and move constant. As the air is moving against it, it's got a constant push up, and as long as the air is moving up here and it's lower, then it's going to be lower than here, and it pushes it up. And so that's how you have a plane lifted, with Bernoulli's and Newton's third law. So that's it, and Merry Christmas.
Ooh, kill him.